Hello everyone! In this video, I wanted to talk about AI agents, their building blocks, their architectures, and by looking at that, I hope that we will also understand what is the difference between or expectations which we might want to have from an AI agent in comparison to AI assistant or AI chatbot. And I looked at different resources to make sure that also I am not just expressing my own opinion, but kind of relying also on the companies which are building those tools. So I collected a lot of different things, dismissed a lot of other things, and here is a list of articles and also a paper which I wanted briefly to cover with you today. If you have something better about this topic, then please don't hesitate to put your links or your message in the comments. So the first one I wanted to start with is actually an article from Antropic, and I will share all the, you will find all the links to these resources in the description field below. But this article is from the December last year in AI Times. We believe this is already ancient, but technically this is a bit more than 3 months ago. And this is a really amazing article about building agents. Here Antropic actually shares their kind of learnings, their approaches, or kind of what they actually see people do with those large language models and what kind of things they are considered to be agents and what are the architectures they see. So here actually the important aspect, so they split, they consider the agent to be anything or agentic system, not agent. So this is actually where the whole vocabulary becomes quite difficult for me at least. But let's say they say that the agent, an agent, can be defined in several ways. Some customers define agents as fully autonomous systems that operate independently over extended periods, while others describe them as a more prescriptive implementations that follow predefined workflows. And at Antropic, they say that all of these variations are agentic systems. So not agents, agentic systems. And then they say that they make a quite important architectural distinction between workflows and agents. So here, workflows are systems where large language models and tools are orchestrated through predefined code path, and agents, on the other hand, are something more complex, where large language model dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. So they also give us a very handy repository, which we will look at in a second. But first, let's look through this article. So they mention that not everything requires agent, so you might actually not even need one. If you don't need one, don't build one. If you do need an agentic system, workflows might be easier, more predictable, more consistent, while agents will be more complex, but again, they are way more powerful. They mention frameworks. They say that also maybe you don't really need a framework because it adds extra layers of abstraction and complexity. So they suggest to start by using the API calls directly to large language model, and then seeing if you actually need a framework, which I totally agree with. Then they mention here actually in this article one building block which they mention is augmented large language model. It's a large language model together with the possibility to retrieve the data, to access the tools, and also store the memory. And they mentioned, and of course they recommend, or actually they say that one approach, it's not really a recommendation, to use the model context protocol for maintaining these augmentations. So if you're interested in that, let me know. I might cover that in the future, but for now it's outside of the scope of this video. So yeah, and then they go into a different ideas of architectures which we might have. So for workflows, there is a number of architectures they mention. First one is a prompt chaining. This is where we just chain calls to large language models. We might want to have some kind of gates there, but then we go from some input information into the final result by just chaining those calls. That's pretty useful, and if you have a clearly defined fixed subtasks into which you can split your task, and here actually you are doing that splitting more or less on your own, so this is not directed by another large language model. This is pretty straightforward in a way that actually you control all those fixed steps. Next one, routing. So here where we have some kind of we can think of some kind of condition, and then we can send depending on the input information, we can send the processing, or let's say the workflow that to a specific large language model. It can be different models, it can be same model, but maybe kind of targeting different aspects. But this is how the routing works. Then we can also do stuff in parallel and then aggregate the results. And these can be both done for speed if we need that, and also for, how they call it, like for higher confidence results. So this is where you might want to evaluate different aspects. So you might try to eliminate some bias in a large language model to balance false positive and negatives. Next one, almost the last one in the workflow list, is orchestrator workers. This is where we have a central large language model which breaks down the tasks and then delegates them to the worker large language models, and then you get the results. And probably the last one is evaluator optimizer. So this is maybe relevant to the judge large language model, where we have, so here in this flow, how it is here on the diagram, we have a model which will generate the output, but then the solution will be sent to another model for a critique or for feedback or for kind of seeing if it's good enough, and then kind of they go there in maybe a cycle till the accepted result is produced. This is quite interesting because also there was a conversation recently which I heard with, I think it's Verdict, they published a paper, and that's a judge, large language model judge library, and the funny thing which I learned from this conversation is that large language models have very strong biases themselves, and they might actually agree more with whatever content produced by the same model and kind of support and consider that correct. In another model, there is a lot of problems actually this evaluation approach. However, still, I guess it's right now widely used and quite interesting. So this is the workflows, and then we go into agents. And agents is the next level. So agents will need to clarify the task, to understand the task, but then once they get the task, they can plan, and we will look into planning a bit later, and they can operate independently. They will come back to a user when they need some kind of information or judgment or something else, but then they can perform the task and hopefully finish the task. They are, let's say, you need really to trust your agent, and we will see the agents such as operator later. If you really can trust that the agent will not do harm to whatever tools you will provide them, and yeah, so this is more or less the diagram which they mentioned. So we have a human who gives the task, and then there is kind of action feedback, and based on the environment or also human feedback, at some point of time the large language model will stop either accomplishing the task or interrupted by the human. And here they mention that the agents can be used for open-ended problems where we cannot predict the required number of steps, and you cannot hard code a fixed path. And they will operate for many turns, and you must have some trust in decision making of that agent. Risks are higher costs, potential for compounding errors. I don't know if I will ever be able to trust financial data to an agent. So those are quite powerful solutions, but also not easy to build and have potentially many complexities. So the summary, they say that it is not about building the most sophisticated system, it is about building the right system for your needs. So this is that first article which I recommend reading. They give some other suggestion. For example, whenever you are writing the prompts, put yourself in the model shoes, which I kind of find quite funny phrasing. But yeah, so kind of think how you can explain to the model what you want to it, and also overcome the limitations by using the language which model can understand. And they also kind of give some examples where it helps them. So in the article there is a link also to the repository, and here they have different notebooks on the examples of the agents and how they work and what kind of prompts they're using. So also check them out. So this is pretty quite readable and kind of not overly complex to understand. So here they actually show a numerous number of the workflows examples, like for example evaluator, optimizer, and kind of what prompts you have there, how you evaluate, how you go into that loop, and so on. So it's pretty useful. So because they mention also two of their own agents, or what they call agents, I looked into those as well. So the second one I wanted to look is this SWE-bench. So we have this SWE-bench website with list of models and the benchmark how they can actually resolve real-world GitHub issues. And then we have the models here, and you can see what is the percentage of the GitHub issues provided to them they can resolve correctly. Because we have unit tests, so we can actually measure how well they resolve those. And at some point of time, Antropic was here at the top with 49, yeah, I guess this one. It was winning this leaderboard. Not anymore, and it hasn't been a long time. It just shows how everything moving pretty quickly. So this is end of October last year. But anyway, so here they actually describe how they create that agent, and this is, I find, pretty interesting because the whole system, not only this SWE-bench, is not only looks at the model itself, but more or less like tooling around it, how you use that model, how you use the prompts, how you are parsing the response, and so on, to get that task of solving those GitHub issues. They show how they kind of talk how they created that agent. They give to the agent, whatever agent they created, they give it as much freedom as possible. So that agent can iterate and try to solve an issue till the model decides that it is finished or exceeds the 200k context length. But they provide this bash tool and editor tool, and the rest is like, model, do your job, or like we don't really try to direct you in any way. and they show some prompts here, what they're using, and of course, like they put it, please change the code, don't change the unit tests. And then like unit tests are run. So not all unit tests are visible, and all in all, 49% of those GitHub issues the model was able to solve. And they used here this thought, action, and observation pattern. So the model was thinking, then was acting, and then observing the result. So all in all, this is one of the examples of the agents. They talk about some kind of complexities here. For example, that it was quite expensive. That also not all issues can be actually solved, but this is more or less the maybe side effect of this benchmark, because sometimes you just have some environment issues or something else. Then kind of this unfair thing, which is there are like hidden tests, and the model doesn't see those tests. I'm not sure if it's unfair, but it is what it is. So this is one of the examples. Then another example of an agent, which is, so this is computer use beta, and this is where okay, this is pretty. Wait, give me a second. I can go here back, and I have that. So I think this is better. So they have this computer use tool, which can look at your screen and make certain actions. And you provide access, of course, to some safe environment. So you don't really want that to have access to any of your sensitive information. But technically, you can tell it a task, like copy some records into the form, or like something monotonous, maybe something which you really don't want to do, which just requires some UI interface, and you just need to do some stupid, silly stuff. And yeah, so and it actually works pretty well. So here, for example, I need to save a picture of a cat to the desktop, and then it goes to the process, and it kind of does that action. A very similar one is not very, I don't know, like how much in capabilities they eventually will be similar, but we also have the operator from ChatGPT. And this is also where you can use operator to perform some tasks, for example, booking your flights, or filling out again forms, and interacting with the web browser operator can help you achieve those goals. And it will do that actions from time to time. It will also can come back to you as a user when it encounters challenge like CAPTCHA or password field. It will pause, and this time it will not record the screen, but other than that, it actually records the screen to process what you have on the screen, where you have those buttons, where you have to click, and so on. So this is pretty cool. Still not really supported in Europe, and I don't know, it probably has something to do with privacy rules or whatever we have. So yes. Then let's move to the last piece which I wanted, because, and this is actually related to the planning. Oh wait, no, that's not really helpful. So the last thing I wanted to look is this paper where they're looking into the planning of an LLM agents, because this is actually the part which makes an agent like next level complexity. And it's nice also to see, so they did a surveys to see how exactly this is done and what kind of tools are used. For example, here we can see this nice diagram. So like what kind of external planner I use: selection, decomposition, memory reflection. And this is not it's kind of older. It's like 1 year old, this paper. But this is the best on the topic which I found, and I think a lot of things are still quite relevant. So here they actually define the main kind of directions different libraries use. So the task decomposition, multi-plan selection, external planner aided planning, and memory augmented planning. So let's look at them into one by one. So the first one, which they find quite important, is how exactly we are making this a list of subtasks based on the task. And there are two approaches. It's just kind of like get initially the whole list of tasks, subtasks which you need, and then go one by one. Or you can actually do it kind of iteratively, so you don't have to predict the whole list of subtasks, how you're going to split your work from the start. You kind of like define the first tasks, and then those are done, you go into the next one. There are pros and cons to this. The problem with splitting this into the whole subset initially is that might be not really the best subtasks you might have. Later you might want actually to iterate and improve, or there may be something which is not super correctly done from the start. However, the second one, which tries to avoid this problem, is kind of thinking one step at a time. Large language models tend to forget the past. So by the time you actually come to the end of that first iteration, the model might really totally forget what was happening in the past, and then you are kind of stuck. So there are like pros and cons to that. And to make that plan, there are different approaches which different libraries or different products do. The one which I think a lot of us have seen is let's think step-by-step instruction. Then also another one is kind of this thought step, action step. So there are a variety of those approaches. Next, they talk about this multi-plan selection. So this is where we start not with one plan. We might start with several plans, and then we select the one which is better. And we can even include kind of external planner aided planning. So not to rely on large language model to create that plan, but actually to use some kind of symbolic planners or neural planners, which are kind of a bit smarter for that particular planning aspect. Then the next one which they discuss is reflection and refinement. And this is where the model tries to make something better, to build that better plan, or to refine on that plan. And there is a reflection stage, which we also saw in a lot of different libraries, where the model tries to reflect on the result of the work which has happened. They also mention the memory aspect. So either it is RAG-based memory or the embodied memory. So embodied memory, this is the large language model memory inside of it, which we need to fine-tune the model. And the RAG-based memory is anything which is outside of that, either in vectors or in other shape or form, where we can bring that knowledge during the request to the large language model as a part of the context. They also talk about evaluation of those planners or agents, and they criticize that there is not really a good benchmark method. So this paper. It's still an interesting read. Not as useful as the stuff from the articles from Antropic, but I think this is like the nature of this type of content. So with this, I hope this was useful. Let me know if you would like to learn more something this kind of direction, or if you have some other topics which you want me to cover. Thank you so much.